I am Megan Weiskarcher. This is Antonio. This is Samuel. And we are talking about the experiment number 3, which is determination of a chemical formula. Why are chemical formulas important? Why are we even spending time to talk about them? Well, they're important because you need to know how many molecules of each element are in the compound so you can repeat the experiment and know how many you'll need. Well, it all started with this guy named Rosellus, who we named the father of chemistry. In the early 1800s, he proposed that chemicals should be named for what they are and not where they come from. So he created this system where they used 1 to 2 letters for the atomic symbols, and then the letters came from the Latin words. Well, then in 1813, he submitted this paper, and it proposed that compounds be described by chemical formulas based on the elemental composition. This led to analytical chemistry, where the number of each element in the molecule, and then they would list them alphabetical order. So they set up these rules for naming compounds, and we call it Hill's order or canonical molecular formula. So if an element is present, then it's written as an atomic symbol with subscripts, and the subscripts are how many number of times the atom of that element is present. But if there's just one, if it's just present one time, then you don't have to start a subscript. If carbon is present, then the carbon counts go first, and then hydrogen counts second, and then with the remaining elements, you list them alphabetically.
In this experiment, we use the law of definite proportions to define the chemical formula for a hydrogen compound containing copper, chloride, and wire molecules locked in the crystal structure of the solid compound. The general formula for the compound is Cu, that means copper, X, Cl, that means chloride, Y, times Z, H2O, that means water. And its name is copper chloride hydrate. The letter X, Y, and Z represent integers that will establish the proper chemical formula for this substance. The objective for this experiment were determine the order of hydration in a copper chloride hydrated sample. Also, conduct a reaction between a solution of copper chloride and solid aluminum. We use the result of the reaction to determine the mass and moles of Cu and Cl, copper and chloride, in this reaction, and calculate the empirical formula of the copper chloride compound. The important materials that we used were a 6M hydrochloric acid HCl solution, 95% ethanol solution, distilled water, and no solid copper chloride hydrate, and also aluminum wire, 20 gauge. The procedure that we used for this experiment were: first, wear or lab goggles or safety glasses all the time during the experiment. That is because some reactions can burn your skin. Second, we measure and record the mass of a crucible without cover, and we obtain 1 gram of copper chloride hydrate and place it into the crucible. We measure and record the mass of the crucible with this compound. Third, we set up our ring stand, ring and state triangle for heating the sample. We rest the crucible on the clay triangle, set up a lab burn, and ignite the burner away from the crucible. We adjusted the burner to get a small flame. Fourth, we took a burner in our hands and we moved the flame slowly back and forth to the crucible to gently heat the sample. We note that the color changed from blue-green to brownish as the wire of hydration is driven out of the crystals. When the sample was turned brown, we gently heat the crucible for like 2 more minutes. We removed and turned off the burner. We covered the crucible with a tape and allowed the sample to cool for about 10 minutes. Once we removed the crucible cover and inspect our sample, we could see if the solution is still blue and green. We had to reheat it again for 2 more minutes until the sample is absolutely brownish.
Measure and record the mass of your cool crucible of your copper chloride sample. Transfer the brown solid to a clean empty 50 ml beaker. Rising on the crucible with 2 ml alcohol aliquot of distilled water. And pour the water into the 50 ml beaker. Gently swirl the beaker to completely dissolve the solid. Note that the color of the solution is green as the copper ions are rehydrated. Measure out about 20 centimeters of aluminum wire. Coil the wire and place the wire in the beaker solution so that it is completely immersed in the copper chloride. Note that the reaction produces gas. Elemental copper is forming on the surface of the aluminum wire, and the color of the solution is fading. The reaction will take about 30 minutes to complete. When the reaction is done, the solution will be colorless. Most of the elemental copper will be on the aluminum wire. Add 5 drops of 6-MHCl solution to dissolve any insoluble aluminum salts in the mixture, which should make the solution clear. Caution: handle the hydrochloric acid with care. It can cause painful burns if it comes in contact with the skin. Use a glass stirring rod to scrape off as much copper as possible from the aluminum wire. Solid the wire up the wall of the beaker and out of the solution with a glass stirrer, raising off any remaining copper with distilled water. If any copper refuses to wash off the aluminum wire, wash it with 1 or 2 drops of 6-MHCl solution and put the aluminum wire aside. Collect and wash the copper producing the reaction. Set up a Bunsen funnel for vacuum filtration. Obtain a piece of filter paper, measure and record mass, and then place the filter paper on the funnel. Start the vacuum filtration. Use small amounts of distilled water to wash all the copper onto a filter paper on the Bunsen funnel. Use the glass stirring rod to break up the larger pieces of copper. Use small amounts of turn off the suction on the vacuum filtration apparatus. Add 10 ml of 95% ethanol to the copper and filter paper and let it sit for about 1 minute. Turn the suction back in and let the vacuum filtration run about 5 minutes. Measure and record the mass of clean, dry watch glass. Transfer the copper to watch glass. Make sure that you have scraped off all the copper onto the watch glass. Dry the watch glass of copper under heat lamp or in a drying oven for 5 minutes. When the watch glass has cooled enough to touch with bare hands, measure the mass of watch glass plus copper. Repeat the dry and wait until you are sure that it's completely dry. Place the copper, aluminum wire, and filter liquid into the collection vessels as directed by the instructor.
Our result for the experiment were the mass of the crucible was 24.37 grams. The mass of the crucible with the hydrated sample that we took at the beginning was 25.17 grams, which means that the mass of the hydrated sample was 0.8 grams. the mass of the crucible with anhydrous sample was 24.97. So the mass of anhydrous sample was 0.6 gram. That means that the mass of the water involved in this experiment was 0.2 grams. These results were after we heat the sample. Then, to measure the copper, we took the mass of the empty wash glass, that it was 38.06 grams, and when we put the copper on it, the mass of wash glass with copper was 38.37 grams. So that means that the mass of the copper was 0.31
In
grams.
this table, we are going to calculate the moles of waters, the mole of copper, the moles of chloride, and the chemical formula of the compound. First, for the moles of water, we take the 0.2 gram of H2O, then we multiply by 1 mole of H2O divided by 18 grams of H2O. Then we got 0.011 moles of H2O. For the moles of copper, we use 0.31 gram of copper. We multiply it by 1 mole of copper over 63.55 grams of copper, and then we got 4.87 exponential -3 moles of copper. For a mole of chloride, first we use 0.6 gram of copper chloride, and we subtract 0.31 gram of copper, and we got with the mass of the Cl, which is 0.29 grams. Then we take that 0.29 gram of chloride, we multiply it by 1 mole of chloride over 5.45 moles of chloride, and we got 8.18 exponential -3 moles of chloride.
To get the chemical formula, we divided the mole of chloride by the mole of copper, so we get a radial mole of 5/3. Then, to get the radial mole of water with copper, we divide the mole of water by the mole of copper, and we get a ratio of 7/3. So the chemical formula that gave us was CO3 Cl5 H2O7.
In this experiment, we had to make sure we were very careful because we had to heat up the sample in the crucible. So we were dealing with open flames with the Bunsen burner and then hydrochloric acid. We did this so we could calculate the mass and the moles. Okay. Next, the solution of copper chloride was mixed with aluminum. Then the next step was done carefully so that we could make sure that we had a small percentage of air. Well, because we had to transfer the solution through the filter paper into the vacuum filtration. This process could affect in the mass of copper and the moles of copper. Finally, the experiment was finished, and then as a few days passed, we went back and to weigh the mass again. We calculated that the percent air for chloride was 0.44%, and then the difference for copper was 25.44%. For the anhydrous sample, there was a 12.53% difference for copper, but for chloride sample, there was a 12.52% difference. So through this experiment, we learned how to calculate the chemical formula.